Hello, Algebra Honors. We're working with Unit 6, which is our unit on exponents and radicals. And day 7, we're going to focus on rationalizing the denominator. And so what that means is we want to have a rational number in the denominator. If I have an example like 4 over the square root of 7 here, the square root of 7 is an irrational number, right? Because it has a decimal that doesn't terminate, it doesn't repeat. So we want a rational number in our denominator. So what we're going to do is manipulate this just so that it looks like there's a rational number in the denominator. All right, that is part of what we have to do if we want to fully simplify an expression. Okay, so there's going to be no radical in the denominator, and we are going to multiply by 1, basically, but we're going to multiply it by a fraction that changes what our numbers look like. Okay, so watch this. 4 over the square root of 7, I'm just going to do this first problem and get us to the answer, and then we'll think about how that works for the rest of the problems as well. I'm multiplying by 1, but my 1 looks like the square root of 7 over the square root of 7. Okay, so the reason I'm doing that is now my numerators are going to be 4 times square root of 7, and my denominator is square root of 7 times square root of 7. If you think about that, that's actually the square root of 7 squared, right? 7 times 7 is 7 squared, and the square root undoes the square. So my answer is 4 square root of 7 over 7. My denominator is now a rational number. It's just a 7. There's no radical in that denominator. Okay, so I'm going to look at 2 over the square root of 3, and to get rid of that radical in the denominator, I'm going to multiply by square root of 3 over square root of 3. So I have in my numerator 2 times the square root of 3 over the square root of 3 times the square root of 3. I'm just going to go straight to that answer is 3. All right, square root of 5 over 2. So here's another thing. When we simplify a radical, we're not allowed to have a fraction as the radicand either. So that's against the rules. So we are going to break this up using our quotient rule. This is the same thing as saying the square root of 5 over the square root of 2. Okay, now oftentimes if I have a fraction under the radical, if there's a way for me to simplify that fraction first, I'll just go ahead and simplify it first. So keep that in mind, because I'll probably do some other problems in a slightly different way. I'm going to multiply by that denominator because that's how I'm going to rationalize it. So I'm going to multiply the upper numbers. My numerator's square root of 5 times square root of 2 is the square root of 10. That's the product rule, right? I can combine those underneath the same radical symbol. The square root of 2 times the square root of 2, we're going to call that just 2. The square root of 10 is the simplest radical form up there in my numerator, and I know that because 10 has factors of 2 times 5, but 2 is not a perfect square and 5 is not a perfect square. So I know I'm good to go there. That's my answer. All right, square root of 81 over 2. That is my next problem. So I don't see a way to simplify that easily, so I'm going to just make this say square root of 81 over square root of 2. Of course, I know the square root of 81 is 9, and so I'm going to say 9 over the square root of 2. And now I'm going to multiply by square root of 2 over square root of 2 because I want to get rid of that denominator. Again, I'm not changing any amounts here. I'm just making them look different. So, so this is the same as if I was adding and subtracting fractions or something, and I knew I needed to say 2/3 plus, I don't know, even 5/6. Okay, so if I needed to do that, we know that we can multiply this fraction 2/3 times 2 over 2, right? And that gives us 4/6 plus 5/6. So that's all we're doing, except that instead of using something normal like 2 over 2, we're just using a radical over a radical. Okay, so that's, just so you know, that's what's happening here. All right, I have 9 times the square root of 2 here, 9 times the square root of 2, and it's all over square root of 2 times square root of 2 is just 2. So again, you're always going to look at your final answer and make sure there's not more simplifying for you to do. Square root of 2, that's as simple as I can get. All right, here is an example of where I might want to simplify first. So watch what I'm going to do. You might think it's not more simple, but I'm going to put everything, kind of undoing my quotient rule, I'm going to put it all back under the same radical, because then I can simplify. So that's going to be the square root of 10 over Oh no, let's divide by 4, sorry. 4 goes into 25 times, and 4 goes into 32 8 times. Okay, so now I'm going to break that up so that it's the square root of 5 over the square root of 8. Need to get rid of that radical in my denominator, so I'm going to multiply by the square root of 8 over the square root of 8. I have the square root of 40 over 8. I am not done, right? Because I know the square root of 40 can be simplified. Okay, that is 4 times 10, so I'm going to jump ahead. The square root of 4 times the square root of 10 is really 2 times the square root of 10. I skipped a step there. I'm not done because I know I can simplify 2/8. So this is going to be just 1 square root of 10 over 4. I simplified my fraction. You could have made this be the square root of 4 times the square root of 5 here. You can make this be the square root of 4 over the square root of 8, right? And anything divided by itself is just 1, so whoop, I'm left with the square root of 5 over the square root of 8, and I'm right here at this point of my work. There are lots of different ways to do these problems. You actually could even multiply the square root of 32 over the square root of 32 if you want. That's just bigger math than I want to do without a calculator, so okay. Square root of 10 over square root of 5. Just for kicks, I'm going to do this a slightly different way. Instead of putting this all in the same radical, I'm going to break up each of these radicals so that I can see that 5 goes into each of them, right? So I'm going to say this is square root of 5 times square root of 2. I'm choosing that because I know I'm going to have square root of 5 down here times the square root of 9. Those cancel. Anything divided by itself is 1. So my answer is the square root of 2 over 3. Can I do anything to simplify my numerator? No. Can I do anything to simplify my denominator? No. And I don't have a radical in the denominator, so that's good. Okay, square root of 6 over 8. I am going to simplify that first. It equals the square root of 1 over 3. Now I'm going to break it up, so that's the square root of 1 over the square root of 3. We know the square root of 1 is 1, right? I can write it if I want to, but I don't have to. Okay, I'm going to multiply. It turns out it doesn't really matter whether I rewrote that with a normal 1 instead of a radical 1. I'm going to multiply by the square root of 3 over the square root of 3, and that gives me square root of 3 over 3, and I can't do anything more than that. Okay, so 8 over 32, I'm going to simplify it first so that I have 1/4. And just like the one that we just did, that gives me the square root of 1 over the square root of 4. I know the square root of 1 is 1, and the square root of 4 is 2. So that's my answer. I don't even have to multiply by radicals, right? Square root of 96 over the square root of 3. 9 plus 6 is 15, and 15 is divisible by 3, so I know 96 is divisible by 3. So I'm doing this, turning that into 96 over 3, and I say that's going to be the square root of 3 goes into 9 3 times, 3 goes into 6 2 times. Square root of 32, I know that that's 16 times 2 because we've been practicing with our perfect squares, so 16 is the big one I want. Square root of 16 times 2, and I make that say 4 times the square root of 2 as my answer. Right here we're exciting because we have a 3 times the square root of 5 all over the square root of 45. So this 3 is outside of the radical, so it just gets multiplied by whatever our final answer is. So it's going to stay outside of the radical for now. I see 3 square root of 5 here, and I know that square root of 45, I can make that be the square root of 5 times the square root of 9. So if you notice that, and you want to objectively get rid of your square roots of 5, you can do it that way. Otherwise, you could have just broken up that 45 the way you normally would simplify a radical. You would have gotten the same answer. Okay, so I now just have 3 over the square root of 9, which is 3 over 3, and I know 3 over 3 is 1. That's my final answer. Again, if you didn't break it up first, if you multiplied by the square root of 45 over the square root of 45, you can do that. The 3 would stay on the outside, and then you would simplify. You would just have bigger math to do. Okay, 7 times the square root of 108 over the square root of 6. I know 6 goes into 108, so watch this. I'm going to write this as 7 times the square root of 108 over 6. This 7 is outside of the radical. It stays outside of the radical. Okay, so I'm going to say that's 7 times the square root of. 6 goes into 10 one time. 6 goes into 48 8 times. And I know that's 7 times the square root of 9 times 2. So I know that's 7 times 3 times the square root of 2. So it's 21 square root of 2. That's my answer. Alrighty, let's take a look. 5 times the square root of 12 over the square root of 10. Just because I'm going to do it a different way. Let's do square root of 10 over square root of 10. Multiplying that. So 5 times square root of 12 times square root of 10. I can multiply those two radicals together in the same house, right? 12 times 10 is 120. This is all over square root of 10 times square root of 10. That's just 10. So, haha, I see that I'm going to be able to simplify, but let me go ahead and, well, I can simplify now. 5 goes into 5 one time, 5 goes into 10 two times. So now I have square root of 120 over 2, and I know that I'm going to be able to break that up. And so that would be, let's see, 4 times 30. That's probably my best bet. So I'm going to say that's the square root of 4 times 30, all in the same house. And that's over 2, so that's going to be 2 times the square root of 30 over 2. And my 2's cancel. And I'm left with square root of 30. So I just want to double check. 30 has factors of 1 times 30, obviously. 2 times 15, those are both not perfect squares. 3 times 10, not perfect squares. 5 times 6, no perfect squares. And 2 times 15, did I say that? So it looks like I don't have any perfect squares as factors, so I'm going to say that is all the way done. All right, a problem like this. Let's go ahead and simplify. 2 goes into 2 one time, 2 goes into 10 5 times. My first step. So I have 5 square root of 48 over square root of square root of 48 over square root of 3. I'm doing 2 steps here because I'm just going to say that that can be under the same radical because I know 3 goes into 48. So this is 5 times the square root of 16, which is 5 times 4, which is 20. Okay. 4 times the square root of 3 over the square root of 2. I'm not allowed to have a radical in the denominator, so I'm going to get rid of it by multiplying by the square root of 2 over square root of 2. 4 times the square root of 3 times the square root of 2. I can multiply those square roots together, so that's going to be the square root of 6. Square root of 2 times square root of 2 is 2, so I have 2 times the square root of 6. Almost done. So 4/6 and square root of 5 over square root of 2. I'm going to simplify. That's going to be 2/3, right? So I have 2 square root of 5 over 3 square root of 2. I need to get rid of that radical in my denominator, so I'm going to multiply by square root of 2 over square root of 2. I get 2 times the square root of 10. Remember, you can multiply those radicals together. It's all over 3 times the square root of 2 times square root of 2 is just 2, so it's times 2. Hey, cancel those 2's. My answer is square root of 10 over 3. All right, this last one. I'm just going to go straight to multiplying by square root of 6 over square root of 6, but again, there are different ways you can do this. This is 2 times the square root of 3 times 6 is 18, so 2 times the square root of 18, all over 3 times 6. Square root of 6 times square root of 6 is 6. So I have 2 square root of 18 over 18. Be careful here, because I know you might be tempted to cancel out those 18s. They cannot cancel, but 2 goes into 2 one time, and 2 goes into 18 9 times. So I have the square root of 18 over 9, but 18 I know has a 9 in there, so I'm going to say that's the square root of 9 times 2, all over 9. Careful and be methodical, because I don't want you to cancel these 9s either. Okay, this is going to be 3 times the square root of 2 over 9, because the square root of 9 is 3. And now I'm going to simplify. 3 goes into 3 one time, and 3 goes into 9 3 times. So my final answer is square root of 2 over 3. All right, thanks for watching.